Hello, welcome to another AQA Multichoice Physics question. If you want to try to answer the question yourself, pause the video now. If you got the answer A, well done. If you didn't and want to hear my explanation, please continue watching. So we've got a 10 microfarad capacitor and it's storing 4.5 millijoules of energy, and then it discharges through a 25 ohm resistor. What is the maximum current during the discharge of the capacitor? Well, the maximum current is going to occur at the initial discharge, right at when the discharge first takes place. That's because the charge will be largest on the capacitor. It's also when the potential difference will be greatest on the capacitor. So I can use the equation current is equal to potential difference over resistance as long as I can find the potential difference. And I can find the potential difference by using the following equation. The energy stored on a capacitor is equal to a half times its capacitance multiplied by potential difference squared. Rearranging, I get potential difference is equal to the square root of 2 times the energy over the capacitance. I can put those numbers into my calculator. 2 times 4.5 times 10 to the minus 3 joules, as found from the question, divided by 10 times 10 to the minus 6 farads, all square rooted, will give me an answer of 30 volts. So now I can go back to this equation. Current equals potential difference over resistance. My potential difference I've just calculated as 30 volts. My resistance were given as 25 ohms. That goes into my calculator and I get an answer of 1.2 amps. Answer A. Hope you're finding these useful. I hope they're helping your revision or helping your learning. If they are, please give a like, please subscribe, and please suggest watching these to your friends. Thank you.